Bernoulli's principle. In 1738, Daniel Bernoulli, a famous Swiss mathematician, published an important article that explained his discovery that moving fluids have a lower pressure than fluids that are still. This discovery also applied to moving and still gases. In honor of Bernoulli and his research, this discovery is now known as Bernoulli's principle. In the discussion of flight, Bernoulli's principle plays a prominent role in explaining how objects fly and also applies to the design of flying vehicles. Seeing is believing, Bernoulli's principle. Here are a couple of very easy experiments that you can do, almost anywhere, that demonstrate Bernoulli's principle. Experiment number 1. This experiment involves a long strip of paper about 5 centimeters by 20 centimeters, in which the experimenter places the paper just below his or her bottom lip and blows over the paper. As you blow across the top of the paper, you are creating air that is moving fast. So the air on top has a lower air pressure. The air below the paper is not moving very much, so it has a higher air pressure. This higher air pressure below tries to move to the lower air pressure on top of the paper, causing the paper to lift up. Experiment number 2. This experiment involves a piece of paper about 8 centimeters by 13 centimeters, in which the paper is folded like a tent and placed on a flat surface. Someone gently blows into the tent. As you blow into the paper tent, you are creating air that is moving fast. So, this air has a lower air pressure than the air above. The air above the tent card is not moving very much, so it has a higher air pressure. The higher air pressure above tries to move to the lower air pressure below, pushing the tent down and flattening it. We can summarize Bernoulli's principle this way. Faster air equals lower pressure. Slower air equals higher pressure. Also, it can be observed that air will always move from an area of higher pressure to an area of lower pressure. Applying Bernoulli's principle to flight. Bernoulli's principle has influenced the design of an airplane's wing. To create lift, we need to produce a low pressure on top of the wing and a high pressure under it. When an aircraft starts to taxi down the runway, its wings disrupt the flow of air. An airplane's wing is curved at the top and flat on the bottom. The curved surface causes the air to be pulled quickly over it, creating a low pressure in relation to the air underneath the wing, which is moving more slowly and at a higher pressure. This difference in pressure contributes to the lift needed for the plane to fly. Other examples of Bernoulli's principle at work. Bernoulli's principle helps to explain many common phenomena, like those listed below. We are going to find out the science behind each example. Spoilers on race cars. Race cars have a similar shape to the wings of an airplane, flat on the bottom and curved on the top. And so race cars traveling at very high speeds experience the same lift as an airplane. To avoid this lift, race cars use spoilers on the back of the car to create a level airflow across the top of the car. This leveling keeps the flow of air even, thereby keeping the air pressure even, and the back wheels of the car stay grounded. Car passing a transport truck. When a car is passing a transport truck or another vehicle, the motion causes the air between the two vehicles to speed up. The speed of the air on the other side of both the car and truck remains the same as it was to begin with. The fast-moving air between the car and the truck results in low air pressure. The air on the other side of the car and the truck is at a higher air pressure. This causes the car to be pushed towards the lower pressure area and also the truck. The driver of the car feels the effect more than the driver of the truck because the car is less heavy than the truck. Rattling windows. Have you ever noticed that windows often rattle on a windy day? Remember that when the wind blows outside, it causes the air to speed up, creating lower air pressure than the higher air pressure inside. The windows start to rattle when the higher air pressure inside tries to go outside to the low air pressure. Curveballs in baseball. Yes, even the science behind a curveball in baseball can, in part, be explained by Bernoulli's principle. When a pitcher throws a curveball, he makes the ball spin very fast. The spinning causes the air pressure on one side of the ball to be higher than on the other side, creating unbalanced air pressure. Naturally, the ball will move towards the area of lower pressure, causing it to curve. Check your understanding. In each diagram below, the area of low pressure has been labeled. Congratulations! You are now an expert on Bernoulli's principle.